Velocity at arbitrary positions in vertical circular motion. Consider a point mass bob of mass m is tied to the string of length r and is performing a vertical circular motion in a vertical plane. Point A is a uppermost position of a bob. Point B is a bottommost position of a bob. Point C and D are midpoint of a bob in a vertical circular motion. At point A, tension TA and weight vector mg both are parallel to each other and directed towards the center of the circular path. At bottommost position B, TB vector directed towards the center of the path and opposite to that of its weight vector mg, which is directed downward direction, but both are lying along the same line. At point C as well as at point D, it is found that their tension vectors are directed towards the center of the circular path, but mg vector is acting downward and both the tension vector and mg vector are perpendicular to each other. So if you consider any arbitrary position in vertical circular motion, we have to resolve the component mg into its two perpendicular vector to see the direction or the speed of this bob while performing vertical circular motion. So at point T1, by considering the alpha angle, mg vector is resolved into its two perpendicular axes, where mg cos alpha is just opposite to that of the tension T1, which is directed towards the center, and mg sin alpha is tangential to this circular path. At point T2, by considering the angle theta, we resolve the component mg into its two perpendicular axes. One is mg cos theta, which is directed along the T2 tension. Both are parallel to each other, whereas mg sin theta, it is tangential to this circular path. So at point T2 and T1, mg vector and T1 are their tension vectors. They are neither parallel to each other or not lying along the same line. So the tangential component gives the direction of the speed of this bob while performing a vertical circular motion. So we can say that the force due to tension and the weight at arbitrary position in vertical circular motion are neither along the same line nor perpendicular to each other, and tangential component of the weight is used to change the speed of this bob in vertical circular motion. And also we can say that the speed of the bob decreases while going up and it is increases while coming down. So when the bob is moving from downmost position to the uppermost position, its potential energy increases and kinetic energy decreases. Hence it is called as retarded motion. Whereas when the bob is moving from point A, that is the uppermost position, to the downmost position, its potential energy decreases and kinetic energy increases. Hence it is called as a accelerated motion.